Programming languages and tools for smart contract development. Smart contracts are self-executing agreements that are written in code and run on a blockchain. To develop smart contracts, developers need to use specific programming languages and tools. In this topic, we will explore the programming languages commonly used for smart contract development and the tools that facilitate the process. Programming languages. Solidity. Solidity is the most popular programming language used for smart contract development. It was developed specifically for Ethereum, one of the most widely used blockchain platforms. Solidity is a statically typed language with similar syntax to JavaScript and is designed to write smart contracts for decentralized apps, dApps. It offers features like inheritance, libraries, and user-defined types. Solidity code is compiled into bytecode that can be executed on the Ethereum Virtual Machine, EVM. Vyper is another programming language designed for Ethereum smart contracts. It aims to enhance security and simplicity compared to Solidity. Vyper has a Python-like syntax and focuses on making the smart contract code more readable and less prone to vulnerabilities. It restricts certain features present in other languages to avoid complex operations and potential risks. Move. Move is a programming language developed by Facebook's Libra Association for the Libra blockchain. It is designed specifically for creating smart contracts and ensures their safety and efficiency. Move provides a resource-oriented programming approach where resources are predefined assets like tokens. It aims to prevent common smart contract vulnerabilities like reentry and has a static type system for added security. Other languages. While Solidity, Vyper, and Move are some of the most popular languages for smart contract development, developers can also use other languages. For example, Ethereum supports languages like Serpent, similar to Python, and LLL, low-level Lisp-like language. Additionally, developers can use general-purpose-like languages like Rust, Python, or JavaScript to create smart contracts by leveraging specific libraries and frameworks. Let's talk about a few tools. Truffle. Truffle is a popular development framework used for Ethereum smart contracts. It provides a suite of tools that makes it easier to create, test, and deploy smart contracts. Truffle enables developers to write contracts in Solidity or Vyper and provides built-in support for automated testing, debugging, and deployment. It also integrates with the Ganache development blockchain, facilitating local development and testing. Remix. Remix is an online integrated development environment, IDE, specifically designed for smart contract development. It supports multiple programming languages like Solidity, Vyper, and Serpent. Remix provides a user-friendly interface to write, compile, and deploy smart contracts. It includes features like coding highlighting, syntax checking, and a built-in debugger. Remix also allows developers to easily interact with deployed contracts for testing purposes. Ganache. Ganache is a personal blockchain network provided by Truffle. It enables developers to create a local development environment where they can deploy and test smart contracts without interacting with the live blockchain network. Ganache provides a suite of features like contract and transaction visualization, in-memory blockchain, and account management. It allows developers to simulate various scenarios and debug their smart contracts before deploying them to the main network. Web3.js. Web3.js is a JavaScript library that allows developers to interact with Ethereum and other blockchain networks. It provides a set of functions to connect to a blockchain, send transactions, and call smart contract methods. Web3.js simplifies the process of integrating smart contracts into decentralized applications by providing an easy-to-use interface for interacting with the blockchain. In summary, programming languages and tools for smart contract development provided learners with an overview of the different programming languages and tools used in the development of smart contracts. This covers popular languages like Solidity, Viper, as well as tools and frameworks like Truffle and Remix. By gaining knowledge and proficiency in these languages and tools, learners will have the necessary skills to write, test, and deploy their own smart contracts effectively. Next up, Ethereum blockchain and smart contract development. Ethereum is a decentralized blockchain platform that enables the development of smart contracts. These smart contracts are self-executing agreements with the terms of the agreement directly written into lines of code. They automatically execute when predetermined conditions are met, eliminating the need for intermediaries in various sectors, such as finance, supply chain, and real estate. In this topic, we will explore the Ethereum blockchain and delve into the process of smart contract development. We will cover essential concepts, tools, and programming languages used to build and deploy contracts on the Ethereum network. Ethereum blockchain. Understanding blockchain technology. Blockchain is a distributed and decentralized ledger that records transactions across a network of computers. Ethereum is built on this blockchain technology and operates as a global computing platform. It enables developers to build applications that run reliably and transparently without any downtime, fraud, or third-party interference. Key features of Ethereum blockchain are the decentralization. Ethereum eliminates the need for intermediaries by allowing participants to interact directly with each other, reducing costs and increasing efficiency. Then there's smart contracts. Smart contracts are the self-executing agreements that automatically execute when the predefined conditions are met. Ethereum enables the development and deployment of smart contracts on its blockchain. And of course, it's immutable and transparent. Once a transaction is recorded on the Ethereum blockchain, it becomes immutable and transparent. This ensures the trust and builds credibility among users. Setting up the development environment. To develop smart contracts on Ethereum, you need to set up your development environment. This involves installing the necessary software, tools, and libraries to write, compile, and deploy smart contracts. Some commonly used tools for smart contract development include Solidity, a programming language specifically designed for writing smart contracts on the Ethereum platform. Remix, a web-based IDE, integrated development environment, that allows you to write, test, and debug smart contracts. Ganache, a personal Ethereum blockchain for local development and testing. It provides a local network where you can deploy and test your own smart contracts. And of course, Truffle, a development framework that simplifies the process of building, testing, and deploying smart contracts. Let's discuss a little bit more about the Solidity programming language. Solidity is a statically typed, high-level programming language specifically designed for writing smart contracts on Ethereum. It has a syntax similar to JavaScript and provides features for creating complex and secure applications. Some key features of Solidity include Contract. The primary building block of Solidity. A contract contains state variables, functions, and modifiers that define the behavior of a smart contract. Data types. Solidity supports various data types, including integers, addresses, strings, and arrays, to store and manipulate data within the smart contracts. Modifiers. Modifiers define the conditions that must be met for a function to be executed. They can be used to add security checks or validate inputs. Events. Events are used to communicate information from a smart contract to the outside world. They can be observed by external applications or scripts to trigger actions. Inheritance. Solidity supports inheritance, allowing you to reuse code and create hierarchies of contracts. Writing and deploying smart contracts. To develop a smart contract, you need to define its structure, data types, and associated functions using Solidity. Once the contract is written, you can compile it using a Solidity compiler like Remix or Truffle. The compilation process generates bytecode, which can then be deployed to the Ethereum blockchain. Deployment of smart contract involves creating a transaction that includes the bytecode of the contract, which is sent to a miner for inclusion in a block. Miners validate the transactions and add it to the blockchain. Once deployed, the smart contract becomes active and can be interacted with using transactions. Interacting with smart contracts. Smart contracts on Ethereum can be interacted with using transactions. Transactions can read or modify the state of the contract by calling its function. They can be initiated through external applications, scripts, or directly using Ethereum addresses. Some common ways to interact with smart contracts include sending transactions. Users can send transactions to execute specific functions within the smart contract. These transactions may require parameters or input values. Listening to events. External applications can listen to events emitted by a smart contract. This allows them to react to specific conditions or trigger actions based on contract events. Reading contract state. Users can read the state of a contract, including its variables or the return values of its specific functions. These provides transparency and visibility into the contract's current state. To summarize, Ethereum blockchain and smart contract development is a crucial topic in understanding the implementation and deployment of smart contracts. This topic covers the Ethereum blockchain platform, its unique features, and the role of smart contracts in this ecosystem. Learners will gain hands-on experience in creating, compiling, and deploying smart contracts on the Ethereum blockchain, along with the understanding of security considerations and best practices for smart contract development.